Hello students, welcome to this lecture on statistics. Today we will cover NCERT section 13.4.1 to 13.4.2 and examples 1 to 5. This is disclaimer. First, we will look at mean deviation for ungrouped data. Then we will look at examples 1 to 3. Next, we move on to mean deviation for group data, specifically for a discrete frequency distribution. Finally, we will look at examples 4 and 5. So make sure you are with your notebooks and pens ready. So let's get started. So we are going to learn how to calculate the mean deviation about the mean, which is a way to measure how spread out a set of numbers is around their average. So let's start by considering a set of n observations, which we will call x1, x2 up to xn with mean x bar. Now let's start step 1. So in step 1, we calculate the mean, which we write as x bar. The formula for the mean is x bar equal to summation xi upon n. So in this formula, x bar is nothing but x1 plus x2 plus dot 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 plus xn upon n. Here xi stands for each individual observation and n is the total number of observations. Step 2 is to calculate the deviations. Okay, this means we find out how far each observation is from the mean. So find the deviations of each observations xi from the mean x bar. So here deviation is denoted by di and di is calculated as xi minus x bar. Step 3 is to find the absolute deviations. Okay, this means we take the absolute value of each deviation. So we ignore whether difference is positive or negative. Okay, so this way we are just interested in how far each value is from the mean, not the direction. So take the absolute value of each deviation. So modulus of di, this is equal to mod of xi minus x bar. Step 4 is to calculate the mean of these absolute deviations. That is, mean deviation x bar equal to summation modulus value of xi minus x bar upon n. Okay, so this means deviation x bar equal to mod of x1 minus x bar plus mod of x2 minus x bar plus dot 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 up to plus xn minus x bar divided upon n. So the mean deviation about the mean is simply the average of the absolute differences between each observation and the mean. Okay. Now let's look at an example to understand how to find the mean deviation about the mean. Okay. So here is a set of data 6, 7, 10, 12, 13, 4, 8 and 12. Okay. And here we have to find the mean deviation about the mean for these data. So first of all, try it yourself. So we are asked to find the mean deviation about the mean for the data set 6, 7, 10, 12, 13, 4, 8 and 12. Okay, so let's solve this example step by step. So we need to calculate the mean deviation about the mean. So this involves two main steps. First, finding the mean of the data, and then finding the average of the absolute differences between each data point and the mean. So let's see now formula. The formula for mean deviation about the mean is mean deviation x bar equal to summation I equal to 1 to n modulus of xi minus x bar upon n, where xi is data point and x bar is mean. And we know that x bar is nothing but equal to summation xi I equal to 1 to n upon n. Okay, so it implies x bar is equal to 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 8 plus 12 upon 8. And here if we sum up 6, 7, 10, 12, 13, 4, 8 and 12, then you will get 72. Okay, so 72, and here total number of observation is 8. So x bar is equal to 72 upon 8, and this is equal to 9. Now let's find the absolute value of the differences between each data point and the mean. Okay, so the respective absolute values of the deviations from mean, that is mod of xi minus x bar, are modulus of 6 minus 9 is 3, modulus of 7 minus 9 is 2. Okay, and so on. You will get all the absolute values of the deviations from mean. Now, sum of absolute deviations is basically summation I equal to 1 to 8 mod value of xi minus x bar. This is equal to 3 plus 2 plus 1 plus 3 plus 4 plus 5 plus 1 plus 3. Okay, and this is equal to 22. So finally, the mean deviation about mean, that is x bar equal to summation I equal to 1 to n mod value of xi minus x bar upon n. Okay, and this is equal to 22 upon 8. And if we calculate further, then you will get this is equal to 2.75. Okay, so mean deviation about mean is here 2.75, and this is our final answer. I hope this example is clear to all of you. Now let's look at example 2. Okay, so in this example we have to understand mean deviation about the mean. So here are the given data set 12, 3, 18, 17, 4, 9, 17, 19, 20, 15, 8, 17, 2, 3, 16, 11, 3, 1, 0, 5. Okay, and here we are asking to find the mean deviation about the mean for these data. So first of all, try it yourself. So let's look at an example problem. Okay, so here how can we solve this example, that we will see step by step. So we need to find mean deviation about the mean using the formula mean deviation x bar equal to summation I equal to 1 to n mod value of xi minus x bar upon n. Okay, where xi is data point and x bar is mean. And we have first to find the mean x bar of the given data. So we know that x bar equal to summation I equal to 1 to n xi upon n. So now put the values of the data from the data set. Okay, 12, 3, 18 and so on. So you will get x bar equal to 12 plus 3 plus 13 plus 17 plus 9 plus 17 plus 19 plus 20 plus 15 plus 8 plus 17 plus 2 plus 3 plus 16 plus 11 plus 3 plus 1 plus 0 plus 5 upon 20. Okay, here 20 is total number of observations. Okay, so just now simplify it and you will get the mean. Okay, x bar. So it implies x bar equal to 200 upon 20 and this is equal to 10. First, let's focus on finding the absolute deviations from the mean for each data point. Okay, so here we will use this formula mod of xi minus x bar. So the respective absolute values of the deviations for from mean are mod value of 12 minus 10 is 2. Then mod value of 3 minus 10 is 7. Okay, and you can easily find the absolute values of the deviations from mean. Okay, so calculate and then find the mean deviations about the mean. Some of the absolute deviations here. Summation I equal to 1 to 20 mod value of xi minus x bar equal to 124. Since mean deviation x bar equal to summation I equal to 1 to n mod value of xi minus x bar upon n, where xi is data point and x bar is mean. So therefore, mean deviation about mean x bar equal to 124 upon 20 and this is equal to 6.2 and this is our final answer. I hope this example is clear to all of you. Now we are going to learn how to calculate the mean deviation about the median. Okay, so this is a method used to measure how much the values in a data set differ from the median value. For a set of n observations, we will call x1, x2 up to xn. The first step is to arrange all the data values in ascending order from the smallest to the largest. Next, we need to calculate the median, okay, which we will call m. If the number of observations n is odd, the median m is the value at the position n plus 1 by 12th observation. If n is even, then median m is the average of the values at position n by 2 and n by 2 plus 1th. Once we have found the median, the next step is to calculate the absolute deviations from the median. Okay, such that mod of xi minus m, where xi is data point and m is the median. Now, in next step 4 is to calculate the mean of these absolute deviations. That is, mean deviation m equal to summation xi minus m upon n. Now note here this point, the sum of deviations from the median is minimum when compared to the sum of deviations from any other value. Okay, so you should note this point. This point is very important point to note. Okay, so note this point. Okay, now let's look at an example number 3. So example number 3 asks us to find the mean deviation about the median for the data 3, 9, 5, 3, 12, 10, 18, 4, 7, 19, 21. Okay, so students, first of all, try it yourself, okay, and then see the solution. So let's solve this example step by step. So first, let's recall what we are being asked to do. Okay, so we need to find the mean deviation about the median. Okay, so we need to find mean deviation about the median using formula. Okay, so try to recall what's formula you know about mean deviation about median. So mean deviation m is equal to summation mod value of xi minus m upon n, where xi are data point and m is median. So for calculating median first, we need to arrange the data in ascending order means smallest to largest. So data will be 3, 3, 4, 5, 7, 9, 10, 12, 18, 19, 21. Here n is 11, which is an odd number. So therefore median is n plus 1 by 2th observation. So it implies m equal to 11 plus 1 by 2th observation, that is 6th observation, and here 6th observation is 9. So median is 9. And so now we will continue solving the rest of the problem. So we know that absolute deviation is given by mod of xi minus m, where xi are data point and m is the median. So here the absolute deviations of the given data about the median are as follows. Okay. Now sum of absolute deviations, summation I equal to 1 to 11 mod of xi minus m. This is equal to 6 plus 6 plus 5 plus 4 plus 2 plus 0 plus 1 plus 3 plus 9 plus 10 plus 12. This is equal to 58. Since mean deviation is equal to summation mod of xi minus m upon n, where xi are data point and m is median and n is the total number of observations. Therefore, mean deviation about median is 58 upon 11, and this is equal to 5.27. I hope this example is clear to all of you and you are getting my point. Now, we will discuss NCT section 13.4.2 mean deviation for group data. Okay, so we know that data can be grouped in two ways. First, discrete frequency distribution. Okay, so for discrete data, we can conclude that mean deviation in two ways. Okay, so about the mean and about the median. And the formula for mean deviation about the mean, you all know, and the formula of mean deviation about the median, okay, that we have already discussed. And the second type is continuous frequency distribution. Okay, so for continuous data, we also calculate mean deviation about the mean and mean deviation about the median. So first, we are going to discuss discrete frequency distribution. Okay, this is a way to organize data when we have a set of distinct values and we want to see how often each value occurs. Okay, so we will break down what this means and how to represent it step by step. So first, let's the given data consist of n distinct values x1, x2 up to xn occurring with frequencies f1, f2 up to fn respectively. Now, notice how we can organize this information in a table. So this table is called a discrete frequency distribution. Here is what the table looks like. The first row lists the values x1, x2 up to xn, and the second row lists their corresponding frequencies f1, f2 up to fn. Now, we are focusing on mean deviation about the mean for discrete frequency distribution. So for data with observations xi and corresponding frequencies fi, step 1 is calculate the mean x bar. So x bar is equal to summation fi xi upon n, where n equal to summation fi. And step 2 is to calculate absolute deviations from the mean, that is mod of xi minus x bar. Step 3 is to calculate how multiply each absolute deviation by its corresponding frequencies. Okay, so that is fi multiplied with modulus of xi minus x bar. Step 4 is for sum these products. Okay, that is summation fi times modulus of xi minus x bar. Step 5 is to divide the sum we just found by the total number of frequency. So the final formula for mean deviation about the mean is summation fi times mod of xi minus x bar upon n. Now we are going to look at how to calculate the mean deviation about the median for a discrete frequency distribution. So for data with observations xi and corresponding frequencies fi, step 1 is to find the median of the dataset, and step 2 is to calculate the absolute deviation from the median for each value xi, and we find the difference between xi and the median m, and then take the absolute value. Okay, so for each data point we compute mod of xi minus m. Step 3 is to multiply each absolute deviations by its corresponding frequency. Okay, that means for each value we calculate fi times mod of xi minus m. Step 4 is to sum up all these products. Okay, in other words, we add together all the fi times mod of xi minus m values for every data point. Step 5 is to divide by the total frequency n. The formula is mean deviation about the mean x bar equal to summation fi times mod xi minus m upon n, where m is median, n is total number of values, fi is frequency of each value, xi is each data set, okay, and data point, and modulus of xi minus m absolute deviation from the median. Now let's look at an example to understand how to find the mean deviation about the mean for our data set. Okay, so here we have a table with two rows. The first row shows the value of xi, which are 2, 5, 6, 8, 10, 12. And the second row shows the corresponding frequencies fi, which are 2, 8, 10, 7, 8, 5. Okay, so we have to find mean deviation about the mean for the following data. So let's solve this example step by step. So we need to find mean deviation about mean using the formula. Mean deviation x bar equal to 1 by n summation fi multiplied with mod of xi minus x bar. Let's represent the data in tabular form. Here, look at this table. In this table, we have the data, okay, of xi, a5 and a5 xi. We here in this table we calculated a5 xi, okay, and we take here total. So total a5 is 40 and summation a5 xi is 300. So we have n equal to summation I equal to 1 to 6, fi equal to 40, and summation I equal to 1 to 6, a5 xi is 300. And we know that x bar equal to 1 by n summation I equal to 1 to 6, a5 xi. Therefore, x bar equal to 1 by 40 times 300, and this is equal to 7.5. Now, again, represent data in tabular form. Here, in this table, in first column, we have xi. In second column, we have a5. In third column, we have a5 xi. In fourth column, we have modulus of xi minus x bar. And in fifth column, we have a5 multiplied with modulus of xi minus x bar. Okay, so we have calculated here each a5 xi and each mod of xi minus x bar and each a5 times xi minus x bar. Okay, and here we total, we get summation a5 is 40, summation a5 xi is 300, and summation a5 times mod of xi minus x bar is 92. Since we know that mean deviation is equal to 1 by n summation a5 times xi minus x bar. From table, we have summation I equal to 1 to 6. a5 times xi minus x bar is 92. So it implies mean deviation x bar equal to 1 by n summation I equal to 1 to 6 a5 times mod of xi minus x bar. This is equal to 1 by 40 times 92, and this is equal to 2.3. Okay, so mean deviation about the mean for the following data is 2.3, and this is our final answer. So I hope this example is clear to all of you. Now let's look at example 5. So in this example, we have defined the mean deviation about the median for the following data. Okay, so in the first row, we have the values of x, and they are 3, 6, 9, 12, 13, 15, 21, and 22. And in second row, we have the values of a5. Okay, so a5 means corresponding frequencies. Okay, so the values of a5 are 3, 4, 5, 9, 3, 4, 5, 2, 4, 5, 4, 3. Okay, so let's solve this example step by step. So to start, we need to recall the formula for mean deviation about the median. Okay, so this formula helps us to measure how much the data values deviate on average, okay, from the median value. So we will use this formula throughout our solution. So here the formula of mean deviation. Mean deviation m is equal to 1 by n summation a5 times modulus of xi minus m. The given observations are already in ascending order. Okay, so we don't need to arrange the given data in ascending order. The given observations are already in ascending order, so adding a row corresponding to cumulative frequencies to the given data, and then we get this table. Okay, so in this table here we have in first row the values of xi, in second row we have the corresponding frequencies fi, and the third row we have cumulative frequency. So now n equal to summation I equal to 1 to 8 a5. This is equal to 30, which is even here. The median is the mean of the 15 and 16 observations. So both of these observations lie in the cumulative frequency 18, for which the corresponding observation is 13. Okay, so note this point. Therefore, median M is equal to 15 observation plus 16 observation upon 2. Okay, and here this is equal to 13 plus 13 upon 2, and this is equal to 13. Now, absolute values of the deviations from median, that is modulus of xi minus m, are shown in the table. So look at this table. In this table, we have absolute values of the deviations from median, mod of xi minus m. Okay, and then we calculated here the multiplication of corresponding frequencies and the absolute values of the deviations from median. So we have summation I equal to 1 to 8 a5 is 30, and summation I equal to 1 to 8 a5 times mod of xi minus m is 149. Since mean deviation about the median is basically 1 by n summation I equal to 1 to 8 a5 times mod of xi minus m. This is equal to 1 by 30 times 149, and this is equal to 4.97. Therefore, mean deviation about the median is 4.97. Okay, and this is the final answer. So I hope this example is clear to all of you. Now we will discuss some extra questions. In this question, we have to find the mean deviation about the mean for the following data. Okay, so in first row we have the values of xi, and in second row we have the values of a5. Okay, so let's solve this question step by step. So we need to find mean deviation about mean using the formula mean deviation x bar equal to 1 by n into summation I equal to 1 to n a5 times mod of xi minus x bar. So let's represent the data in tabular form. In this tabular form, you can see in first column the values of xi. In second column, we have values of a5, and in third column, we calculated the values of a5 multiplied with xi, and we total here a5 is okay. So the corresponding sum of corresponding frequencies is 20 here, and the sum of a5 xi is 433. So from table we have n equal to summation I equal to 1 to 5 a5 is equal to 20, and summation I equal to 1 to 5 a5 xi is 433. And we know that x bar equal to 1 by n summation I equal to 1 to 5 a5 xi. Therefore, x bar equal to 1 by 20 times 433, and this is equal to 21.65. Now again, represent data in tabular form. So in this tabular form, here we calculated the values of absolute deviations from the mean mod of xi minus x bar, and we calculated the product of a5 and mod of xi minus x bar. Okay. Since we know that mean deviation is equal to 1 by n summation I equal to 1 to n a5 times mod of xi minus x bar. So from table we have summation I equal to 1 to 5 a5 times mod of xi minus x bar is 25. So it implies mean deviation is equal to 1 by n summation I equal to 1 to 5 a5 times mod of xi minus x bar. This is equal to 1 by 20 times 25, and this is equal to 1.25. Now look at this question. In this question, we have to find the mean deviation about the median of the following distribution. Okay. So in this table, in first row, we have the values of xi and they are 10, 11, 12, 14 and 15. And in second row, we have the values of the corresponding frequencies a5. They are 2, 3, 8, 3, 4. Okay. So we have to find the mean deviation about the median of the following distribution. So let's solve this question. We need to find mean deviation about median using formula. Mean deviation is equal to 1 by n summation I equal to 1 to n a5 times mod of xi minus m. And the given observations are already in ascending order. And here adding a row corresponding to cumulative frequencies to the given data, and then we get this table. Okay, so in this table here you can observe in the first row the values of xi, in second row the values of the corresponding frequencies. Now n equal to summation I equal to 1 to 5 a5, this is equal to 20, which is even. Therefore the median is the mean of the 10th and 11th observations. Both the 10th and 11th observations fall within the cumulative frequency of 13, which means both are the value of 12. Therefore median m is 10th observation plus 11th observation upon 2, and this is equal to 12 plus 12 upon 2 is equal to 12. So now absolute values of the deviations from median, that is mod of xi minus m, are shown in the table. So look at this table. Here in this table we have absolute values of the deviations from the median, and we calculated the product of the corresponding frequencies and absolute values of the deviations from median. And we have summation I equal to 1 to 5 a5 is 20, and summation I equal to 1 to 5 a5 times mod of xi minus m is 25. Since mean deviation about the median is equal to 1 by n summation I equal to 1 to 5 a5 times mod of xi minus m, this is equal to 1 by 20 times 25, this is equal to 1.25. Therefore mean deviation about the median is 1.25. So I hope this question is clear to all of you. So students, that's all for today's lecture, and thank you for your attention. I hope this lesson was helpful to all of you.